My name is Gulshan Banu, working as an assistant professor, AI and DS department. As a part of teaching learning process, SNS College of Institution actually promotes faculties to take video lectures even through YouTube and connect students through YouTube and have them connected even through that. So as a part of that, today we are here with a new topic from deep learning. The topic and the unit that we are going to see is the unit 3, dimensionality reduction. The topic that we are going to see today is linear, that is PCA and LDA and the manifolds that is included in this unit. Okay. So now before getting into what is PCA and LDA and manifolds process, we will look upon what are all certain limitations of logistic regression. Okay, we have certain limitations, that is it is limited only to binary classification problem, that is when you have two classes it will be accessible. Now it can be unstable when classes are well separated, and it is unstable for low number of examples. Okay, now what we are going to see is what is the linear discriminant analysis. The linear method for multi-class classification problem, and it projects the features in high dimensional spaces in low dimensional space. Okay, say for example, if you have an image or any kind of object that you want to project through image, and the image is in the low dimensional process and you want to project in a high dimensional process, you will be using this linear discriminant analysis. Okay, now we will see how the process is. You will be assuming the data in Gaussian and consistent variant. Okay, LDA estimates the mean and variance just to find out the property of the image that you are going to access. Now what is dimensionality reduction for LDA is it projects the data into lower dimension and it creates a new axis and projects the data on the new axis. That is, you will be creating a process. Okay, so that process you will be having n number of data sets, and that projection should be given in one single line or one single process, right? For that you will be using this LDA. Now see how the process is being executed. See, you will be having different kinds of images and you will plot the axis for it, and that is dimensionally executed, and it has been divided into different parts, and it will be easy for you to recognize which process is going in the proper manner. This is the dimensionality reduction in the different kinds of views of how the LDA is being executed. So what is the issue with this high dimensional data is classifying accuracy becomes saturated upon addition of features, and features corresponding to dimensions is actually very high over here. Now what is the relationship to overfitting? Overfitting is nothing but you have to include more and more images. We will be including more and more images at the same process, so more features is equal to more likely to overfit. Dimensionality reduction is usually done to prevent the chances of overfitting. Okay, now we will see what is PCA, that is principal component analysis. What is this principal component analysis? Principal component analysis is nothing but it rotates and projects the data along the directions of increasing the variance. It will be used for continuous data. So now the principal components are the features will be having with the maximum variance. See, now in this we have given the examples or the differentiation of how the PCA and LDA will be done. So in the LDA, it maximizes the component axis for class separation. Okay. Now in PCA, component axis are maximizes the variance. See, in this there is a class separation, and in this you have a single process. In that you are having different kinds of variations that is associated in the single process. So that is the difference between these two things. See, we have given an example of how the PCA is being executed. So PCA is useful for eliminating the dimensions below we have plotted the data as a pair of lines, one composed of the x values and the other composed of the y values. See, the data is being plotted in the actual manner. Now the output will be this in the second process. That is, if you are going to only see the data along one dimensional through, it might be better to make the dimension the principal component with most variant. We don't have to lose as many as dropping PC2, since it contributes the least to the variation in the data sets. Okay, now this is an example of how it is being executed. Here are some examples of how those data and it has been plotted in an efficient way. Okay, now we have to see like what is the curve of dimensionality is all about, and what is the process actually. So in next video we will see the continuation of this process. So in this video we saw what is PCA and what is the first what we saw what is the disadvantages of the logical regression is. We saw what is PCA and we saw what is LDA and what is the process of how the images is being classified. In the next video I will be meeting you out with the continuation of this process, and we will see some other concepts which is related with it. As of now, thank you. Have a good day.